model with linear functions. We are going to, let's start by reviewing a little bit of what we did on the past couple of lessons. First of all, to write the line of equation, given the slope and the y-intercept, we use the slope-intercept form, right? Given the slope and a point, we use the point-slope form, and given 2 points, we first use slope and then the point-slope form to find. It says the graph shows the distance Allison hikes x hour, that's very important, that is x hours. Write an equation of the line I interpreted the slope. How long does it take Allison to hike 14 miles? So this is the line. So let's go here and let's say we use the point 0, 0. So I got the point 0, 0 and 7.27 and 24.5. Let's start by finding the slope. So 24.5 minus 0 divided by 7 minus 0. So this equals to 24.5 divided by 7. So this is 3.5. That's my slope. The slope on this case, because this is interpret the slope, is the speed that Allison is walking. So Allison is walking 3.5 miles per hour. Right? So my equation equals to 3.5 x. Now to find how long it takes her to travel 14 hours, we're just going to substitute 14 for x. Actually, no. We are going to substitute 14 for y because we're finding the time, right? The 14 is the distance. I'm going to divide by 3.5 and x equals to 4 hours. Now, the next one says Kelly and Kim are both babysitters. Kelly charges a flat fee of 20 plus 6 per hour. So we know that x is going to be the hours they work to babysit. The table shows the hourly fee that Kim charges to babysit. Who charges more per hour and how many hours must Kim and Kelly babysit for their total fees to be the same? So by looking at the table, we know that Kim, and I'm going to show you why, charges $4 per hour. And she charges a flat fee of 18. How do we know that? Because the difference between hour per hour is just 4, right? So 22 to here, this is plus 4, then plus 4 over here, plus 4 over here. Because she charges per hour $4, that means that she started at 18, so her flat fee is 18. With this, we can establish the first question, who charges more? So that means that Kelly charges more. Now, it says how many hours must Kim and Kelly babysit? Of course, you can do a table for Kelly too, but I'm going to show you with equation. So Kelly works charges $10 a flat fee plus $6 per hour. So how much she charges per hour? We're going to multiply 6 times how many hours she babysit, and to that we are in 10. Kim, in the other hand, Kim, let's name Kim and let's say A just to give them a different name. It's going to be 18 flat fee plus 4 times x. And we want to know when those two equations equal to each other. So to solve this equation, I'm going to start by subtracting 4x. So that means that I got 10 plus 2x equals to 18, then minus 10 on both sides. So 2x equals to 8 and divided by 2. That means that they have to work 4 hours to charge the same. Now, there's just some data that you cannot have an exact relation. When the data is a scatter plot show an approximate line relations, you can model the line with a line of phi, right? This line of phi is not going to be exact. Why? Because you can have more than one answer, more than one correct answer on the axis. To create a line of phi, we're going to create a scatter plot. So that means that we're going to plug the information on a coordinate plane. Let's sketch the graph. The most closely appears to follow the trend given by the data point. Then choose to point on the line and estimate the coordinate of the points. Write an equation of the line that passes through the points from step 3. So that means that we're going to go to the calculator and do this. We're going to plug that information. To do that, we're going to go to Stat. We're going to go to Edit. And then on whatever list you have there, I have list 1 and list 2. Keep that in mind. I'm going to write the x values. So I'm going to write the x values. Then I'm going to write the y values on L2. And I'm going to go now to, once I write that information, I'm going to go down to second stat plot up here. I'm going to choose the first one, and I'm going to turn it on. That way my calculator is going to plug that information. Another thing, keep in mind that all of those values are positive. That means that we're working in quadrant 1. So we're going to go to window. We're going to have 0 for x. I'm putting x maximum to 11. So that means, so that 10 is not just in the border, so we can have a little bit more space. And then y minimum, y maximum to 10. And I'm going to trace my graph. And as you can see, this line, this is not linear because you can see that we have points over here or here. There's not a line that passes through. Right? So we can choose any 2 points there to trace the graph. I want to choose, let's say this one, and let's say this one. So that means that that point is point, so it's 1, 2, 3, 4. So 1, 2, 3, 4. So it's point 7 and 4.45, and then point 6 and 4. All right, so I'm choosing this point. So I'm choosing this highlighted there. I'm choosing this point, and I'm choosing this one. Right, so I'm going to start by finding the slope there. So my slope is 4 minus 4.45 divided by 6 minus 7, so 0.45 negative, so 0.45. With that, I'm going to use the point slope form. So y minus 4 equals to 0.45 0.45 x minus 6. So I'm going to distribute equals to 0.45 x minus 2.7 plus 4 on both sides. That means that y equals to 0.45 x plus 1.3. That's my equation of best fit, or line of fit. Sorry, not the best fit. That best fit is the other part. So the line of fit. Now, with this one, I want to find how much it costs to have a 0.45 times 8 plus 3. So 0.45 times 8 plus 1.3, 1.3, not 3, 1.3 equals 249. Okay. Now, there's a line of best fit, right? And that's a line that it lies as close as possible to all the data points. Now, this one we have to do it in the calculator. To find the exact value, we're going to use the linear regression on your calculator. Again, I already plugged that information to my calculator, right? That's why I have it here. Now I'm going to go back to stat, but in this case, now I'm going to move to calc, right there. And then I'm going to choose number 4. Keep in mind that this is AX plus B, so I'm going to use number 4 right there, right? Line list 1, I have mine on list 1. If you, by any chance on your calculator, have it in a different list, you just change it there by seeing that you have it there, so you can press second L1 or L2 or L3, whatever you need. The same with the y values, and then you can leave the other parts blank, and then we're going to go to calc here. And this is the values of my line of best fit. So that means that my slope, remember that we saw it over here. Let's go back so you can see it, right? Right here, right? We saw that A is the slope, B is the y-intercept. Right? Okay, so that means that my slope is 0.51. And then my b value, my y-intercept is 0.87. So that means that my line of best fit is y equals to 0.51x plus 0.87. Right? So let's write this right here. Let's write it here. So I get 0.51. Again, I'm going to here to y equals to 0.51x plus 0.87. And I'm going to trace my graph. And there you have the graph that is a little bit close to every single point. That's the best fit of the line. Now with that, I'm going to find y equals to 0.51 times 8 plus 0.87, and I'm going to show you something on your calculator. First of all, I got to make sure that I know that 8 was inside of my window. If it's not, if we're finding a value that is not inside of the window, we got to go back here and change the x value. But in this case, y, the 8 is inside of that one because we are between 0 and 11. Now I'm going to go back to the graph, and I'm going to go second cog, and I'm going to go to number 1, that is the value. And in this case, I'm going to write the 8. So that means that the actual cost of a 8 ounce of fruit is going to be 4.95. And as you can see, we were not that far away from the 4.90. And that's it for this lesson. May the fourth be with you.